All right, good afternoon, everybody. Want to thank everybody for making some time today to listen to our webinar. We're really excited to kind of focus once again our month of September on all things STEAM, or Steamtember as we so lovingly refer to it. So we've been, trying to share a lot of different resources on LinkedIn and through some emails about getting your STEAM systems up and running and, using ultrasound for your steam trap testing and things like that. So we're really excited today to have some folks from the Iowa Department of Natural Resources here to talk to us about their pollution prevention internship program and the great success that they've had in setting that up, and then actually getting some really cool results from using their ultrasound equipment on their steam traps. So should be a really cool webinar and a little bit different. So for those of you who've been on webinars with us in the past, this is the first time we've got multiple presenters and in multiple locations. So, hopefully this is going to all run as smoothly as we practiced yesterday. I have full confidence that it will. So before I turn things over to Daniil, who's going to go first, just kind of our typical housekeeping items. So they are letting us record this, so that's great. So if anybody needs to hop off early, or if you've got a colleague that wasn't going to be able to make it, we'll have that available on our website, hopefully later this afternoon. So if you're interested in that, you can check the website or shoot me an email, and I'm happy to send you the direct link to it. So want to make that clear. We also welcome questions, so try and make this as interactive as we can, knowing that we're all kind of spread out throughout the country. But there is a little place where you can type those questions in, and I'll be monitoring those, and I'll get those tossed over to our presenters as it makes sense throughout the presentation, or of course at the end we'll make some time for some additional Q&A as well. And then just always love to throw out the little caveat that, we are doing this live, and we do have a few extra factors with the multiple presenters today. So if we have any audio issues or any technical issues, just know that we'll do our best to jump on those real quick and get them resolved. But I think it's more beneficial to do these live and give people an opportunity to interact than to try and make it absolutely perfect by pre-recording these. So with all that said, I am going to change the screen over here to Daniil and let her introduce herself and the team here and get started.
Okay. Thank you, Maureen. Today, I'm going to kind of introduce people as we go through, but I have two presenters with me today. Sarah Mim is an engineer with our P2 intern program, and then one of the interns that worked with our program will be presenting also. But so my name is Daniil, and I want to start out by sharing a little bit about the program to give you an idea of the framework and the context that these projects were completed in. So Pollution Prevention Services is a program of the Iowa Department of Natural Resources, and our mission statement is to conserve and enhance our natural resources. So, and that's what pollution prevention is all about. It's utilizing our resources more efficiently to reduce negative impacts on our environment and save money doing it. So this slide shows the pollution prevention hierarchy that is kind of our guiding concept. But the key concept here is to go up the pipe and stop or reduce the waste from happening in the first place. We want to reduce it at the source instead of trying to treat or dispose it at the end of the process. So in the case of steam, which is our topic of the day, our goal is to conserve water, energy, and possibly pre-treatment chemicals that are used to generate the steam. So Pollution Prevention Services provides technical assistance to businesses and industries in Iowa with two goals, as we mentioned earlier: to improve environmental performance at their facility by applying the P2 principles, and to save them money. A couple things that I want to note: the because we are housed in a regulatory agency, the Iowa Code protects the proprietary information of the companies that we assist. So today's webinar, we're focusing on the beneficial use of the webinars in addressing steam and boiler efficiency projects. Any company information that you see shared today has been taken from case summaries, and that's all been pre-approved by the host companies for us to share publicly. So we'll do our best to answer questions, but please understand there may be some of the questions that we can't go into detail with because of we are limited on that. And I don't know if it's going to affect today's project, but also our interns are not trained to assess regulatory compliance issues. But it is helpful to know that sometimes the recommendations that the interns have can be limited by regulatory issues that the companies are under. So that could or could not affect the recommendations sometimes. So I used the 2018 class because the two of the projects that we're highlighting today were done in 2018, and then the other one was actually produced in our case summary book of that year. But in the summer, our program ramps up our technical team with upper level engineering students to work on site with the host companies. So these interns, they spend their first week in a rigorous training session. They learn how to conduct assessments, how to do the data collection and documentation. And then they spend the remainder of their internship at their assigned company doing the project. They're going to collect data, in-depth data, so that the companies can act on that. So today, as we mentioned, we're going to highlight a couple of steam reduction and boiler efficiency projects that these students did. So again, the interns help us meeting our goals by conducting in-depth data collection and research. Our goal is to get the depth of information so that companies can make informed decisions regarding implementation and their environmental performance strategies. So with that, I'm going to turn it over. Our first intern speaker, Andrew, had a conflict come up. So I'm going to turn it over to one of our technical advisors, Sarah Mem. She's an engineer with our P2 team, and she's going to share some input that Andrew provided us regarding his project.
Thank you, Danielle. So Andrew is a mechanical engineering student at Iowa State University, and as you can see, he completed his internship in 2018 at Cambrex in Charles City, Iowa. The basis of Andrew's project was to complete a survey of the steam and condensate return systems and make recommendations to improve the efficiency of the system and reduce associated costs. So we're going to start out by showing how a steam trap works. So basically, steam traps are a type of automatic valve that filters out condensate or condensed steam and non-condensable gases, basically air, without letting steam escape. In industry, steam is used regularly for heating or for mechanical power. There are different types of steam traps, but their purpose is the same, and that is to ensure that steam is not wasted. An ultrasonic leak detector allows you to hear the trap opening and closing as it works. You can hear if a trap is not working or if it is not functioning at full capacity. A trap that is failed open provides a continuous signal, and a trap failed closed produces no signal on the ultrasonic leak detector. At Cambrex, the intern used an ultrasonic leak detector to identify inefficiencies in the steam system, including leaks and the status of the traps. In general, interns who focus on steam projects haven't worked on a steam system, and for many of them, this is the first time they are in an industrial facility. Not only do they have to learn the processes contained within the facility, but they have to learn how specific components work and interact within those processes. Spending a bit of time practicing with the equipment and learning how to apply it to the system helps them identify when something is amiss. One of the challenges that Andrew shared with us was that due to some facilities having different pressures of steam, when using the ULD, it can sound different between a higher pressure and a lower pressure. Knowing the differences can take practice to know what to listen for and accurately denoting if the trap is just leaking or if it is completely failed. Another common issue is knowing if the trap is in service and blocked or if it is failed closed. If a trap is blocked, it can be unblocked without having to change out the trap, but if it is failed closed, the trap will have to be replaced completely. Knowing the difference can save money on buying steam traps and can usually be detected with an infrared camera or a non-contact thermometer. By fixing or replacing these failed traps, a facility can see significant water and natural gas savings, as well as cost savings. To calculate the baseline of the steam system, Andrew first had to determine the loss of the steam and condensate from the faulty steam trap, as well as the utility expenses for water and natural gas. Using these values, he was able to calculate the cost of steam by using the amount of energy it takes to heat the water to steam. Steam traps were attached to various size pipes, so knowing the pressure at each application is critical to calculate losses for each specific trap. Culminating all of the losses, the potential savings can be calculated for fixing the current failed and leaking traps, as well as the savings from an ongoing maintenance program. Overall, the ULD has proven helpful to interns to identify and quantify leaking or failed traps. As long as you know the type of trap you are analyzing and what it sounds like when it is operational versus not operational, the ULD is a great tool to assist with a steam system analysis. On the screen, you can see some of the savings and recommendations that Andrew had presented. And so these are the potential and projected water and natural gas savings and chemical savings that he produced from doing his steam system audit. We can take a couple of questions as we transfer the screen to Badrinath to share his project experience with the steam and boiler efficiency project.
All right, so far no questions, but don't be shy, folks. Feel free to type those in whenever. But I think we're good to transfer over if you guys are ready.
Yes, I'm ready, Neil.
All right, here we go. Hold on one second, folks.
Try pulling this back up, maybe.
All right. So, hi. My name is Badrinath. I have a master's in mechanical engineering, and I was 2018 P2 intern at ABS ultrasound, where main project objective was basically to reduce steam usage, and also put in a PM plan in place for steam trap in the facility. So I had to conduct an assessment of the steam system and improve the efficiency by reducing the steam demand, and also develop an implementation and ongoing maintenance plan to maintain the efficiency of the system. Now the main challenge, in a facility like ABS is that, it's basically a really, really, really big facility, and it's also like a really old facility, which means that the steam system there is also really, really old. And without proper maintenance, that can, for instance, JBS has about 300 to 400 traps in the facility itself. So, without proper maintenance, without having a proper maintenance plan, fix steam leaks, or fix steam traps, without having a proper preventative maintenance plan, things will get very difficult because you will lose a lot of money due to steam leaks or traps failing. So that is this potential money going down the drain, as well as basically, if you save steam, the savings are twofold, because you save natural gas as well as water. Of course, the proportion of water you save is a much smaller proportion than that of natural gas. But basically, it basically gives you a double benefit, as well as like, by basically saving on natural gas, water, you can also save on emissions. You can also save like, on like basically other chemicals you treat the water going into the boiler, because, if you basically reduce steam demand, that leads to like, basically like a basically lesser fuel being consumed by the boiler, and then as a result, lesser makeup water like, being required by the boiler. And yeah, that's where you're gonna get your water savings from. And yeah, since the boiler is gonna require less water as well, you're gonna require less chemical to treat it. So, I mean, if you save steam, you will save a lot of other things as well, in addition to money. And especially like, in really huge old facilities that have like a steam heating system. I think having like a preventive maintenance plan in place, and like, being really, 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 really vigilant about like steam usage is like really important, like from an environmental perspective as well as a financial perspective for the organization. Moving on. So yeah, in my project, like, I am going to talk about like basically two of the projects that I did, which was like, a steam leak detection survey, where, I had to go, I mean, like, I went around the facility, like, using an UltraProbe 9000 ultrasonic leak detector, to detect steam leaks throughout the plant, and it was really, 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 really useful. Um, uh, uh, like, yeah, especially in a facility as big and as huge as JBS. Um, like, the presence of the ULD was, I mean, like, was a big help, because, I mean, like, see, basically, like, it's like really easy to use, and it's also fun to use. And I mean, so yeah, I basically used the ULD to detect steam leaks in the plant. I went around the plant, and like, I used the ULD to basically adjust sensitivity and everything. Like, I mean, like, as you might be aware, like, the ULD has different sensitivity settings. You start off with the core setting, and then you move to the finer setting once you get closer to the source of the steam leak, and then you can actually find. I mean, like, then that helps you actually hone in and find the leak and actually store information regarding it. So that's really helpful, because a lot of steam leaks, there aren't really visible. Of course, you have some leaks that are like, very visible, like, they have, I mean, like, some steam pipes that are blown off, and you don't really need the ULD to detect that. But I mean, but basically in an active facility, or like, or like, in an active plant area, yeah, there's going to be a lot of steam leaks that you can't really see with your eyes. And um, yeah, that's where the ULD comes in really, really, really handy. And that's where I used it, to basically detect yeah, to basically detect the steam leaks in the facility. And like, I also quantified the amount that the company lost in terms of steam and money and water and like other things. And yeah, so yeah, other than that, like, my next project was to like, recommend like a preventative maintenance plan, like for the steam traps of the company. So like, so far I've been talking about steam leaks, but yeah, the company had about 300 to 400 like steam traps. And um, like it's actually really, 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 really important to have like a maintenance plan in place to maintain those steam traps, because if you don't, traps will fail. And and yeah, that just leads to basically continuous steam loss. And believe it or not, that is a lot of money wasted. So yeah, I basically use the ULD to assist me in like, sampling certain traps, and like, finding the percentage of traps that had failed at the facility. And then I quantified the amount, and then I basically compared multiple different preventive maintenance programs for the company, based on the failure rate, of the steam traps and other boiler parameters, steam pressure, temperature, and all that. With that, I basically compared multiple maintenance plans, multiple preventative maintenance plans, for example, bi-monthly inspection, a monthly inspection, a yearly inspection, a yearly replacement, a monthly replacement, a bi-monthly replacement, and based on based on my findings, I found that a bi-monthly inspection was the best PM plan for the facility, based on the number of steam traps, the failure rate, and other parameters. And yeah, the ULT was very helpful, to me in this endeavor as well, to basically I can quantify and verify the failure rate of these steam traps. So my two projects, the steam leak repair project, led to an annual cost savings of about $11,000, and a projected water savings of about 160,000 gallons, and natural gas savings of about 27,000 terms. And steam trap PM program that I recommended led to will lead to an annual cost savings of $76,000 approximately, a projected water savings of about 1.2 million gallons, and a projected natural gas savings of about 210,000 terms. Now other than that, it's also important to note that this was just a piece of the pie in terms of steam usage and steam savings, because I approached because basically I approached the project, which was basically increase the efficiency of the system by reducing steam demand from from basically a three-pronged standpoint, the first prong being detect steam leaks and repair them immediately. The second prong being put in a PM plan for the steam traps in the facility, because there is no current PM PM plan in place. So recommend a PM plan for the steam traps in the facility. And the third was basically a process-based approach. Basically in a facility as big as JBS, there are multiple processes that actually use steam. And I went about reducing steam from a process-based standpoint by conducting an assessment first and looking at which processes use the most steam, and then I just focused on two or three of those processes, and I came up with ways where we could use steam more efficiently, or where we could use much less steam to achieve the same result, or where we could do the or where we could do the process more efficiently and achieve the same result, and thereby saving the organization money, and also reducing steam usage, reducing emissions, saving water, saving chemicals. So.
Hey, real quick question that someone just popped in. So as you're showing those results there, they just were wondering if those numbers were for the entire plant for all 400 traps, or what do those represent? Just some clarification.
Oh yeah, that's for all 400 traps in the facility. That is the PM. The PM program was set up for all the traps in the facility as a whole. So yes, the savings and all the numbers on there are for all the traps in the facility, not for one individualized trap. It's for all 400 traps put together.
All right, great. Thank you.
Of course. That is it from my end. I had a very enjoyable time, actually carrying out this project. I learned a lot. So basically, my thanks to the P2 team, for actually being, great assistance to me throughout this project, and, for actually, letting me do this project. And, the ULD as well was a great help. And without that, I would not have been able to, finish my project and achieve the results that I achieved. So Yeah,
Well,
that
that's
is all
great.
I have.
Awesome. Cool. All right. So I'm going to send the presentation back over to you, Danielle and Sarah. And there you go.
You see us?
Yes.
So the last project that we want to highlight, this is a project that was done at a state facility. Ethan Moran was a mechanical engineering student. Oh, yep, fix that. Was a mechanical engineering student, again, at Iowa State University. And this project was at a 100-year-old facility. It's operated by the Iowa Department of Natural Resources. And the main purpose of the facility is to provide services it acts as a licensed intermediate residential care facility for intellectually disabled individuals. And their mission is to prepare and support individuals so that they can live in a community of their choice. So they've got both residential and day facilities, but approximately 130 individuals live on campus, supported by about 500 employees in the intermediate care facility. They also have a juvenile treatment facility on site, which is called the Woodward Academy, and they lease building space located on the campus. And the Woodward Academy provides education and clinical services in a residential setting for approximately 265 students. And then, Woodward Academy is operated 24 hours a day, 365 days a year. And then the local school district also leases building space, and it's utilized as a standalone special needs day school for, it's based on a state-defined consortium model, but it's for the local residents that need additional services for education. But that part is just the day facility. So the facility, it uses steam heating system for the 19 buildings on campus. And it's also used for clothes dryers, kitchen appliances, chillers, and room heating. And two 50-year-old, they've got two 50-year-old water tube boilers, natural gas boilers that produce the steam. And then it's delivered to approximately 475,000 square feet of building space through an 8,000-foot utility tunnel system. And more than 50% of the components of this 50-year-old steam system had not been replaced since the steam system was originally installed. So we knew this was going to be a pretty large project, given the age and the layout of the campus, but also with the complexity of the system. We knew it was going to need extensive documentation, being a state facility. It was going to need additional documentation just to be implemented as a government project. So we set this up originally as a 24-week project. So that's what this intern committed to right up front, was working on site for 24 weeks. And he stayed busy for the entire time. So again, this intern used the ultrasonic leak detector supplemented with an infrared thermographic camera. The camera gives them, once they identify issues, sometimes they can tell, it gives them additional information on the opening, closing, what's going on in that trap. And it also helps them identify areas in places that they can't reach as well. They can get that from a little bit further distance away. So from the initial observations, this intern concluded that the trap and installation repairs would both yield the highest energy opportunities or energy savings opportunities. But he also realized that the efficiency of the distribution system really had to be addressed and corrected before he could calculate the actual capacity needed of the boilers for the amount of steam generation that was actually needed once the system was operating efficiently. So the data that he collected during the surveys was compiled into a database, and he included the location, trap specifications, current trap status, and then he also documented the insulation of the piping. His survey and data collection revealed that more than 75% of the steam produced was being lost due to the steam traps, leaks, and poor insulation. So it was really operating pretty inefficiently. And so you can see by correcting the amount of potential there is, or the amount of loss that can be had in a system that's not operating efficiently. But leaks in the steam system, they can also add demand to the boiler, and they create pressure drops in the system, so it leads to an insufficient supply where it's needed. Cost savings and other benefits of a regular maintenance plan. An efficiently operating steam system will go far beyond eliminating steam leaks and noises in your steam system. Almost every project that we do for steam leaks, steam traps, and compressed air, they all include a component for the maintenance, ongoing maintenance, because you can correct them, but they continue to go bad, and you need to stay on top of that in order to keep your system working efficiently. And we kind of operate, there's a statistic, the US Department of Energy publication has a statistic that states approximately 20% of steam can be lost to leaking traps in a typical distribution system that does not have a preventative maintenance plan, ongoing preventative maintenance program. So we kind of look at that system and think that if we can stay on top of, once we get these steam systems operating efficiently for the companies, hopefully they can stay on top of them. And that's the number that we typically use for calculating the maintenance program for companies to save, unless they have documentation that we can show that it's different than that. But another thing to keep in mind is that all of these, the steam distribution system is part of a larger overall system. It's just one of the parts that you have to keep operating, but any one of these can affect the others. But an inefficient steam distribution system, it's going to affect the amount of steam that you have to generate. It's going to affect the efficiency of the rest of the system. So this is the place that we recommend that our interns start with their systems. So that's what we have for you. Have any questions come in, Maureen?
Yeah, actually, so someone was just asking, again, how many steam traps were at the site you were just talking about, and then how many of them needed repairs after the inspections were done?
I don't have that right in front of me on the number of traps, but I believe, I don't have that in front of me. I believe there was over 1,000 traps, though.
Ooh, a lot.
Yeah.
Okay, no problem, no problem. All
there
right,
was,
so yeah,
there
go
was
ahead.
The steam lines themselves, there's 475,000 feet of steam lines. The tunnels are 8,000 foot long. It's all distributed in a steam tunnel, and the tunnels themselves were 8,000 foot, but yeah, there was a lot.
No doubt, that is.
And that has actually, so this project concluded in the fall of 2017, and they were starting the final phase. They did it in stages, and they had all of the traps that needed to be purchased were purchased early this spring, and they were in the final stages of implementation going into that in the spring. I couldn't get a hold of the site supervisor, but I believe that it was scheduled to finish up either 1st of September or 1st of October before we went into the cold season. So the last time we talked with him, yes, they were on track, and they were recognizing, they think the savings is actually going to be higher than what was documented.
Oh, awesome. So someone was
Yeah.
just asking for just to kind of talk a little bit about the training that these students got to know how to determine, a good trap versus a bad trap. So maybe you can talk a little bit about the training that went into this.
Okay. The initial training that we do is a week of training curriculum where they learn to do assessments and how to use some of the equipment. We provide the instruction manuals for the equipment to them in advance. They get them electronically, and we ask them to go through that. But then when they get the equipment, we encourage them to just kind of walk around and spend a little bit of time learning to working with the system and learning what different things, what they're hearing and how it's sounding, and comparing that. We do a exercise at our training too with using the warblers, where we hide them and they have to go and find the warblers. And that just kind of gets them some hands-on, gets them used to using the equipment and playing with it a little bit. But experience, that's the big thing, experience. And then they also have been in pretty close contact with UE systems when there's an issue come up or they hear something and they don't understand the sound or what they're hearing. The support at UE Systems has been really instrumental in helping them to be successful with their projects.
I promise I did not pay her to say that, but we do appreciate that, and certainly we are here to help anybody, with their programs. So always keep that in mind to use us as a resource for sure. Right. Well, that's really great, and for those of you who might be considering something like this or wondering about getting training on using ultrasound for STEAM, I'll do a kind of a shameless plug that we do have an online training course for that. And so, it's something that you can sign up for and take, at your desk, at your convenience, log in and do a module during lunch and then go in the next day and do it again. So, so that's just something to keep in mind, that it's a pretty affordable way to not have to travel somewhere and get that training, or at least get a jump start on it. Certainly getting some hands-on time, as you mentioned, is also critical. So we can certainly help with that also. So another question came in as we were talking about that. So someone's asking, can you talk about the changes in plant behavior after your interns leave the plant? Did they move forward with better inspection habits and maintenance habits? What kind of worked and what didn't work now that you're kind of on the other side of it?
Is this from an intern perspective or from a company perspective?
I think they're more wondering, like, from a plant perspective. Yeah, after the
how the companies do
wrapped up.
Okay.
Yeah.
Well, if early on we talk about money being a driver. When the students get their projects, when we're first setting the projects up, that's what we want to work with the company on, is what is their driver for implementation? Is it environmental performance? Is it a compliance issue that they're trying to change the way they're doing something that will affect a compliance issue? Or is it money? And usually seeing the savings in this is eye-opening for companies, especially like compressed air. The perception is that air is free, right? But the cost to generate that air can be quite expensive. And it's the same way with steam. In much of the United States, water is pretty inexpensive as well. But the cost to heat that water and generate the steam can be really expensive and increase their costs exponentially. So that's the first thing, is to make sure that we well document how we're calculating their savings and make sure that accuracy is important. But then we also follow up with the companies. We start at about 3 months and make sure that they understand what the report was, the information in there, did they have any questions on it? And then we check up with them on 6-month intervals on the implementation phase. Have things been implemented? If not, why not? And what can we do to help them overcome those barriers? Because we're part of the Department of Natural Resources and we're grant funded. So we have to account for the implementation of our projects. So yes, we do regular follow-ups with the companies and document and do troubleshooting to follow up on those projects. But for the most part, most of them, they're participating in the program because they have a driver that's driving the project and a reason that they want to improve in the first place. So implementation that's the fun part of our job, is following up on everything.
Awesome. Yeah, and of course, we always talk document, make your successes known, and share those great results. That's the best way to keep momentum going and keep these programs, moving full steam ahead. Okay. So I did that. All right. Well, that looks like it's all for the questions for today. But want to thank all of you so much for putting this webinar on for us today. Really great information. I mean, the results certainly speak for themselves. So if anybody has, additional questions after you hop off here and you've thought about things a little bit more, certainly don't hesitate to reach out to me and I can get you in touch with our presenters from today to help you out to get that information. So I'm just going to take the screen back. So I'm going to leave this up on the screen here so you have our contact info. So if anybody has any questions at all about what they talked about today or want to get any more information about utilizing ultrasound for STEAM, we've got a wealth of information on our website, so you can check that out. But with that, I'll let everybody head on their way. And again, Daniil and Sarah and Badrinath, thank you so much. And hope everybody has a great rest of your day. And we'll hopefully see you back next month when we do another webinar. All right?
Thank you.
Thank you.
Thank you so much, Maureen.
Awesome. All right, guys. We'll catch you guys later.
Okay.